All right, welcome to today's lecture. We are starting our, our physics calculation today. Okay, like I promised, I'm going to treat all the high yield calculation topics. All right, so today we are starting with dimensions. All right, dimensions. So even though you know how to solve dimension before, just listening to this lecture, take this lecture, you are going to learn one or two new things from this lecture. All right, let's go. What are dimensions? They are fundamental quantities. Dimensions are fundamental quantities. That's the component of dimension, and they include what? M, which stands for mass, L, which stands for length, and T, which stands for time. These three are the what? The fundamental what? Quantities. Okay? The fundamental quantities, mass, length, time. So dimension is simply converting a unit. Converting a unit to, you convert a unit of a quantity to this mass, length, and time. You reduce that unit of that quantity to this, you represent it with this mass, length, and time. That's what dimensions. Alright? Now let's look at the steps of dimension. Alright? The first step of dimension is define. Define the quantity first. After defining it, you write the formula of the quantity through the definition. After writing the formula of the quantity through the definition, what do you do next? You do what? The dimension. You convert that formula to mass, length, and time. Then after converting the formula, you do what? You compute everything. You now bring everything together to get the dimension of that quantity. Very easy. Now, let's start with the first example. The first example here is dimension of speed. What is the dimension of speed? Let's find out. Before we start, let's quickly look at an important consideration before we start dimension. All right? Use mass for any unit related to mass. That's, we are going to use M for any unit related to mass. For example, kilogram. Maybe in the unit it was represented in kilogram. You see kilogram there. That means you will represent that kilogram with mass. The second one says use length for any unit related to length. That's, you are going to use L. Look at it, L for any unit related to what? Length. All right? So, for example, meters. If it's meters, use L. If it's kilometers, use what? L. Then the final one, use time, which is T. Use T for any unit related to time. Look at it. For example, second. Maybe you now see second there. You use what? T. The first example with these steps and this consideration. All right? The first example here is the dimension of speed. First of all, the first thing that we have to do is, following this step, we have to define speed. And what is speed? So speed is defined as the distance covered with time. That's the what? The definition of speed. So we are going to do what? The second step, which is what? You write out the formula of speed. Speed now is equal to, we use that definition to write the formula of speed. Distance over time. Okay? This is the formula for what? Speed. Alright? So what are we going to do now? We have to write out the dimensions. Distance and time. We have to convert them to this what? These fundamental units. Alright? So for distance, we are going to use what? Distance. Okay? Distance is related to what? Length. Length. We are going to use what? L. Time is related to what? I know you know it already. It's even represented with the what? The fundamental unit here as time. So we use what? T. So for us to now write out this dimension of speed, what's the next thing? To compute. We compute everything together using basic what? Mathematics. How do we compute everything together? Remember what the formula says, speed. Then our speed will now be equal to L, put the L in bracket, over T. Alright. So we are computing the dimension now. Alright. So what is the next thing to do now? Therefore, we are now going to have speed. Will now give us what? This L. Okay. L divided by T is now going to be 1 over L over T. Using mathematics, L is equal to T raised to power minus 1. Alright. So this is the dimension of speed. Alright. So now, let's move over to example 2. Example 2 here is what? The dimension of what? Velocity. It says find the dimension of what? Velocity. And we are going to follow the first step. What's the first step? You define first. And what is the definition of velocity? Velocity is the what? The change of rate of displacement with time taken. So velocity V is equal to what? Displacement over what? Time. Okay. Then what are we going to do? We have written the formula through the definition. The next thing is to do the dimension with the what? The three fundamental units. Alright. So what are we going to do? Displacement is the distance moved in a specific direction. So we are going to use length anywhere we see displacement. Then for time, we are going to use what? T anywhere we see what? Time. Alright. So we are now going to do what? We compute it. So if we compute it, we are now going to have V is equal to displacement. We are now going to have L, put it in bracket, L over, what are we going to put here? T, put it in brackets. Okay. Then if we rearrange this mathematically, we are now going to have what? The same thing that we did for speed here. 1 over L over T. We are now going to have what? This one will come this side. It will now be V, our velocity, equal to what? L times what? T raised to power minus 1. This is the dimension of what? Velocity. Alright. So let's move over to the next. Let's do a more, a more complex one. So example 3 says dimension of acceleration. How do we do the dimension of acceleration? Following the rules. The first rule is to what? Define. Okay, so we are going to do what? Define acceleration right away. All right, so to define acceleration, let's represent it as A is equal to what? Though acceleration is represented in small letter a, okay, or let's just represent it. Let me just cancel it. So acceleration is equal to what? Acceleration is this change of rate of velocity per time or with time taking. All right, so velocity over what? Time. So this is the formula of what? Acceleration. So velocity is what? What is velocity? Meter per second. That's distance with time. All right, so velocity is telling us about distance. So we are going to use what for distance? L. So A is equal to, where we have velocity, we put L there, over time. What is time? T. Here we have time, we put what? We put T there. All right, so I want you to not forget something. Velocity is equal to what? Meter per second. That's what? Distance times what? Time. All right, so since velocity is distance times time, we already use D as L here, so we are going to put time for velocity. So we are going to put T here. Since we have velocity here, we are going to do the dimension of velocity first of all. All right, we are going to know the dimension of velocity before we include it with time. We already did the dimension of velocity before, and what we got was L t minus 1. The dimension of velocity and the dimension of speed are the same. Okay, so this is the dimension of velocity. So if we put everything here, it's now going to be A, which is acceleration, is equal to L, okay, L t raised to power minus 1 over t. Put it in what? In bracket. This one now will be together because this one is one dimension. All right, so since this is what we have, we are now going to do what? We are now going to compute it. Okay, so if we compute this and this will now give us t squared. So we are now going to have A is equal to L t raised to power minus 2. Okay, this times this t squared. All right, so this is the dimension of acceleration. All right, for the fourth example, let's do the dimension of force. All right, first of all, we have to do what? Define force. What is force? Force is that which change a body state of rest, and force is given by force is equal to what? Mass times what? Acceleration. Okay, mass times acceleration. Okay, so if force is given by mass times acceleration, we are going to do the what? The dimension of mass and the dimension of acceleration. All right, so therefore our force is equal to what? Since force is a derived unit, let me write out the unit of force. The unit of force is kilogram meter second square. Kilogram meter second square. All right, or Newton. Okay, Newton. Any of these, okay, is the unit of force. Okay, unit. Okay, all right, so what we have here is mass. We are going to put it here as m, okay, times the dimension of acceleration. We've already done the dimension of acceleration. So what's the dimension of acceleration? L t raised to power minus 2. So we are going to put it as what? L t raised to power minus 2. Okay, so this is the dimension of acceleration. All right, so what are we going to do now? We are now going to compute this. Therefore F is equal to what? M, since it's only one m we have here, and is what? Is away from this. They don't join together. We are now going to be left with m raised to power 1 L raised to power 1 t raised to power minus 2. All right, L, that's 1L, 1m, and t raised to power what? Minus 2. So the dimension of force is m raised to power 1 L raised to power 1. That's 1m, 1L, t raised to power what? 2. All right, so you can see any of these in your option. Okay, so pick the one you see. So m raised to power 1 is also m. All right, L raised to power 1 is also L. Okay, so for your assignment, do for energy density. So do the dimension. Thank you for taking this class. See you in the next class.